Welcome to Duality Check, the podcast where two brothers embark on a journey through the realms of scientific inquiry, the mysteries of the past, and the uncharted realms of spirituality. Join us as we explore the wonders of our world and beyond, all while embracing the roles of curious bystanders rather than experts. Together we'll unravel the tapestry of existence, blending the dichotomies of knowledge and wonder. Get ready to question, ponder, and delve into the dualities that shape our understanding of reality on Duality Check. I'm Drew.
And I'm Dean, and this is episode 27.
Welcome. So
we are post-Cosmic
Summit 2024. And we planned on watching it all weekend. We did. But it was a... yeah, you tell them what happened to you on Saturday.
Yeah.
I was just busy doing family stuff.
Yeah, you're a dad. You got lots of excuses.
Yeah.
For me, I was tired. I stayed up too late the night before. But I did wake up at 5:30 in order to catch the beginning of the conference at 8:30. And
you went to bed at 2 probably, I'm assuming.
Yeah. So I'm on like no sleep. But of course, because it's 5:30 and I'm tired as heck, I didn't get out of bed to watch it, but I put it on. And then I saw I got the intro, and then I got maybe a couple minutes. I don't even think I necessarily fully made it to Chris Cottrell's talk. And then I just fell asleep. And then I woke up a couple times and kept, catching a few minutes here and there and then just falling back to sleep.
Yeah, you're especially on a weekend, you're not getting up usually, especially you go to bed at 2, you're not waking up till noon.
Right. So I didn't think that through. But when I finally was like up and at 'em and out of my bed and like ready to like really pay attention was the perfect timing because it was when everything was going into the main hall after the yin and yang tracks. And so I caught Chandra Wickramasinghe.
Mm-hmm.
He told us how to pronounce it.
Yeah.
Which was honestly going to be my highlight of the whole show anyway. So I caught him. And then I caught Randall's talk and I caught Malcom Bendall's talk. Randall's talk, though, his voice is just too soothing to me.
I know, man.
If you're anywhere comfortable, like you're gonna fall asleep.
Yeah, anytime I watch anything with him, and even on Joe Rogan or something, like if I put him on a night, I'll fall asleep, and I have to rewatch him like 2 or 3 times before I really sink in all the information. Because
he was the last one on the main stage that night, and so like I had already watched those other talks, and then I went from my sitting position on the couch because I like put it up on the TV and everything to like,
decline.
And then I like switched to like sitting sideways on the couch and then I sunk in a little bit. Next thing you know, I'm like laying down watching and then of course I've passed out.
Blanket somehow mysteriously comes on top.
But I woke back up, so I kind of caught bits and pieces of his talk, but I want to go back and listen to it.
I didn't get to listen to his... is it a different topic than he usually talks about in general? I'm sure we can talk about it a little bit, but I know you want to go back to it.
Yeah, what was his topic?
Because he covers a wide range, whether it's younger dry stuff or
lots of stuff.
Dragons.
I don't know if he got to the main thrust by the time I passed out.
Okay.
But I woke up and I caught his Q&A session.
Yeah.
And
I'm sure people were asking him all sorts of shit.
Yeah, people were asking him about aliens. And
everybody wants to know about his theories.
He said he's preparing something about the moon right now.
That's going to be cool.
But he was like, no comment. Well, I will comment, and my comment is that I'm preparing something.
He always does that.
Yeah.
I love Randall and all of his stuff. I wish I would have. I'm going to go back and watch it because we can go back on the thing.
Right.
And watch
We've got the on-demand videos now.
So I did watch all of Malcom Bendall's, which right off the bat, before we even talk about any of the content of it, the whole. I just wanted to address the whole awkwardness of him at the end. them trying to get him to answer questions from the live stream audience, and he was just I mean, there was people that were already made their way up to the stage at the floor, and they were like asking him questions, taking pictures, like trying to get him all of his attention and stuff. And then he had like the people who were putting on the event trying to Johanna and the other guy,
right? And then they were like, "We just everything." Give up.
They're like, and it was funny because it was all on mic, and I'm sure they're looking back and it's all kind of a goof up, but just like the AV was a little bit wonky where like mics were live randomly and you just like hear people talking.
Yeah.
But anyway, I just wanted to address that because I thought it was funny. Then I was like, at the end, I was like, oh my gosh, this is kind of tough. But it was like in between sessions.
But the people he brought up on stage with him, some of them were really interesting.
Yeah. Agree.
Look forward to talking about that. And then since then, and then the Sunday, we had Father's Day and a whole golf trip planned. So we didn't catch any of the Sunday
we didn't really watch anything Sunday. I was Saturday just busy, couldn't do anything. Sunday, busy, fell asleep because I just got a little toasty.
Right. And then,
came home, fell asleep.
Yeah. And then Monday was work. So I didn't catch any of the classroom stuff. I don't know. Was that stuff available on demand? I didn't know.
I didn't actually look. No, I didn't look. I think there was like a button for it. I don't know. Maybe not. Anyway, I don't know. Before we start and go into any of it, I just wanted to.
But since then, I've caught Chris Cottrell's talk too.
Oh, okay. So you've got a few people that went.
Yeah.
I definitely have some notes and stuff I want to go over with like my thoughts on like Chandra's talks and stuff. And I've listened to other talks of his before too, so I don't know. Just little things that I want to bring up. And then, but yeah, before we get started, I just wanted to do kind of our outro before to change up so just want to tell everybody, if you've gotten this far, to like and subscribe if you're on YouTube or Rumble, or I don't know how it is on podcasts.
Yeah,
I know they can like it and rate it, right?
It depends on what podcast player they're listening on. Someone had reported to us that they couldn't figure out how to leave a rating on iTunes, and I tried to, and I couldn't either. So I haven't checked on that recently.
Well, if not, and you're feeling generous, we'll go over to the YouTube or come on Instagram and Facebook, and we post every week when we drop the episodes. So right before we drop the episode, or right at the same time we drop the episodes, usually. But yeah, you can come on YouTube, like, subscribe, comment, share.
If you listen on Spotify and you listen through, or at least far enough through, then you can leave a rating.
Oh,
and
gotcha.
Description and whatnot.
It might be same on Apple then.
Maybe, but I think on Apple you can leave a review for the show and not for an episode, whereas for Spotify it's for the episode.
Individual episodes. Got it. Anyway,
I don't see a way
if you see a way to.
But even if you listen through the podcast, it would help us immensely if you have YouTube to sign into your YouTube and just give us a like and subscribe.
Yep.
Just will really help our channel start to
get more eyes,
get more ears, get more people,
hopefully
conversation. One day we'll have enough listeners to like get a hold of or get the attention of the algorithm, but whatever.
And even in the meantime, just build up a community of people who want to chat about this stuff.
Right. And that's what's nice about listening on YouTube also, is there's the comment section, and it's easy for you guys to engage with each other about the topics as well. So
yeah, we got plans for the future as far as like potentially going to like a video podcast where we can present this stuff, get some guests on, stuff like that. So live streaming some episodes might not be out of possibility in the future, which would be fun to get some people involved.
It would be.
Get some questions, stuff like that. Yeah. A lot of plans. We're doing small and incremental upgrades to the podcast. We got some shock mounts to help out with my table taps.
There should be,
It's a little better. We're tapping right now, if you can't tell.
Yeah.
It's good.
There was a lot of I tried to edit some of those out, but almost every time you did it, you were talking, or one of us was talking.
There was maybe a few times where,
And it was weird last week too because my mic is mounted to your desk, so every time you tapped, like the sound would actually come through my mic more than yours.
Yeah.
But
because you were talking too, there's like a gate, isn't there?
No. I think it's just because where it's mounted on your table, maybe. It's like further from the legs, so it's got less to dampen the vibrations.
That could be.
But anyway.
Too much.
So you said you had like a story or something you wanted to talk about?
So yeah, I got a article in Time magazine.
Drop that in the show notes for me.
Yeah.
But yeah, what you got?
And it is on AI's the ChatGPT and OpenAI, the issue with hallucinations in the AI programming and the models. And how they plan to, hold on, let me get to this.
How they plan to get it to stop
hallucinating. What they're doing to try to fix it. So it says here, an enduring problem in today's generative artificial intelligence tools like ChatGPT is that they often confidently assert false information. AKA, they've been calling it the hallucination.
Right.
And it's a key barrier to AI's usefulness. Hallucinations have led to some embarrassing public slip-ups. In February, Air Canada was forced by the tribunal to honor a discount that its customer support chatbot had mistakenly offered to a passenger.
Oops.
In May, Google was forced to make changes to its new AI overviews search feature after the bot told some users that it was safe to eat rocks.
It gets worse than that. Oh my God, there's so many funny ones that the Google was telling people to do.
Oh, yeah.
Yeah, there's hilarious ones.
And then there's another one in June. 2 lawyers were fined $5,000 by a U.S. judge after one of them admitted he had used the ChatGPT to help write a court filing. He came clean because the chatbot had added fake citations to the submission, which pointed to cases that never existed.
Yep. I heard about that as well.
Oh, man. So yeah, there's a new way that they're trying to fix these things, which I thought was pretty interesting. So the methodology, the methods used in the study to detect whether a model is likely to be confabulating is relatively simple. And so the confabulations, basically, I'll go back real quick to get some context. It's when the AI model spits out inconsistent wrong answers to a factual question, as opposed to the same consistent wrong answer, which is more likely to stem from problems with the model's training data.
Right.
Model lying in pursuit of a reward or structural failure in a model's logic or reasoning. It's difficult to quantify what the percentage of all AI hallucinations are confabulations, but it's likely to be very large. So back to the methodology. Their example of what they're going to be doing is they're going to ask it between 5 to 10 questions, the same prompt, and then ask for. They're going to answer the same prompt. And use basically, so there's an example. Paris is the capital of France. This is one of the answers. And then if it gets another answer is France's capital is capital city is Paris. That would be assigned to a group. And then answers like France's capital is Rome would be assigned to another group. So they're calling it semantic entropy. In other words, a measure of how similar or different the meanings of each answer are. And if the model's answers all have different meanings, the semantic entropy score would be high. So they're trying to and this is supposedly their most accurate way of detecting and finding the root cause of it. So what they're to get a low semantic entropy score, you'd have to have either consistently right answers, obviously, or consistent answers, whether it be wrong. As long as it's consistent, that's the way they can tell whether it's confabulating or if it's just has bad data. Which is interesting. It's just interesting, this idea that, I mean, obviously, it's just a term that they're using to describe it. The hallucination.
Yeah. So
AI.
I've been listening to a podcast. I haven't finished it with Lex Friedman this week. He had on the founder of Perplexity AI. And I don't know if you heard of them yet, but their product is essentially, they call it a knowledge engine or whatever, or like an answer engine. So like it's targeting something like Google, but instead of like how like a Google search works right now, where like you get like an AI answer at the top and then a bunch of traditional Google links.
Right.
They're trying to make the entire thing like an AI answer with references. So their goal is to, if you have a question, the AI's job is to answer it and give you links places to go to follow up, rather than like
the traditional
search
list
model
of things.
Right.
Like you get like a response, like a written or maybe in the future audio response to your question. And then there's links for you to click on instead of it, but it'll be in like and this is what this is, and this, and then here's the reference to that, and then you click a link. And
so why they say this is they on there, he said that they have less hallucination issues than all the other large language models. And he said it was because of how they set it up. So like what they do is they make it so that when you enter a search, it will search the web for, articles or whatever that pertain to your search. It'll pick whatever are the top rated ones that it chooses based on whatever criteria. It'll read them, and then it will assemble everything it learned into an answer for you. So
it'll basically read a lot, like read through and give you summaries of it, and then spit it back as an answer to the question you're pointing to.
Right. So it's not just answering from its large training data. It's answering based on the search it just made based on your question.
And what's in the searches.
And what's in the results of that. And then it's providing those links for everything it read in context.
That's crazy.
And so by doing it that way, they said they're able to have a lot less hallucination because it is essentially targeted to basically answer based off of the text that it read.
Yeah, it's basically doing the search for you without, like, it's doing all of the things you would do immediately after typing something into Google.
Right.
You'd go through and you'd read through all the different lists, or you'd click on different links and get different perspectives based on the different information's sources you have.
Right.
And then you would have to put that together in your head. But it's doing it in a more thoughtful way, where it's doing it quicker, and then it's putting it together, and it's putting it in such a way that you are likely to understand the information better. And the hallucination thing makes sense, like it not having hallucinations if it's basically doing what you do when you search the internet. And
because the difference between this and ChatGPT is when you ask something to ChatGPT, you can ask it to do a Google search and it can do that, but like that's not what it's designed to do. It's designed to pull from its training data and use statistics to essentially autocomplete based off of your question.
Which almost intrinsically is going to cause these hallucinations.
Yeah, well,
because there's the end goal is to answer it the most efficient way.
Well, the end goal for the AI is to like get whatever award points to say it's a good AI from,
Right. But it doesn't seem like this Perplexity AI is after that same kind of thing. Like its main function is like
it's just a multi-step process, like it's not only answering based off of your question and its training data. It then goes, it searches, it reads, and it synthesizes that into its answer.
Yeah, and it uses its training data to help answer it in a way that you would understand based on the context of the question, right?
Right. It's the training data that makes it the smart large language
but then
model
it
that
uses
makes it capable
the
of reading and using natural language and summarizing.
So basically,
and all
you would
that
have
stuff.
to write a long ass prompt to ChatGPT saying, "This is my question, and I want you to use these parameters. I want you to only search for articles and use that information when you respond." And your response can be, you just have to like really spell it out for it what you want.
Right.
This
and
is
that's
like,
where like the ChatGPT apps come in. Like if you're I don't even think you need this subscription anymore. But if you go into ChatGPT, there's different GPTs you can browse through, and those are anyone can make those. If you're like a developer, you can go in and you can essentially give it instructions on like what to do when you ask it something, and so you
that's
can
where
make
these
your own
image generators are coming from.
Right. And so people have made ones that will like fill more of that style role, but yeah, GPT as a whole, like it's more just there
generally
to talk.
Right. It's more the mods that people are putting on it and using its model to utilize.
Yeah,
it's pretty cool.
But
the music one you were talking about is pretty interesting.
It's pretty funny the types of ways people are getting in trouble by using it, though.
I know. I wish there was more examples because I didn't know there was so many.
I've seen people like posting online about like getting accused of their like college papers or their school papers.
Yeah, no, I'm sure that does happen a lot.
Right, but I've seen people who they're like, so I didn't use AI, but the teacher uses AI to detect AI, and their AI detected my paper as AI, even though I wrote it.
Oh my god.
And so, like, that's a whole thing,
now the teacher's
too.
getting called out for using AI to detect.
Right.
Oh, man. Such a crazy, crazy world where
I know
things are moving to. So, yeah, that was it all I had. It was just interesting that they're doing all this work and trying to make it better. But I thought that was also funny, the stories.
Yeah, dude, I gotta look up some of these. These are freaking hilarious.
So I've got another one.
Go ahead.
Unless you can get this quick.
I'll search while.
Okay. This is just another article on that I ran across. Where am I on? Clearerthinking.org about the Mandela Effect and how collective memories can sometimes be inaccurate. Investigating the Mandela Effect. So basically, they were talking about like these visual cases, the visual stuff, like the logos and the things that are visual, the Mandela Effect.
Yeah,
and they are they're doing research to try to. I mean, they're basically trying to disprove that it's a real effect. But a recent study found evidence that the visual Mandela effect reflecting apparent collective false memories of images. For example, the Monopoly man above. There's an image
the monocle
with the monocle or not, or glasses or not. The correct depiction is no glasses, no monocle, as far as what history tells you.
Right.
And then they did a bunch of these other studies with people that. So the recent study found that the visual Mandela effect reflecting apparent collective false memories of images, like the Monopoly Man, were depicted as part of a transparent replications project, which aims to run replications of published psychology papers from top journals shortly after they were published. We ran a replication of this study. Is the Mandela effect real? It absolutely is. When we ran into the study from scratch on a new set of participants, we found that the same exact effect as the original paper. How it was shown to exist that this effect is real is why does it exist? In this article, we're going to explain the replication study and think critically about some of the explanations. So their study found that people often mistake a fake version of the image for the real one. There's a low accuracy in identifying the correct image. There's a specific common mistake people will make people make with the image, like thinking the Monopoly Man has a monocle. People make the same mistake. Lots of people will make the same mistake. Even if the people say the correct image looks familiar, they still often get it wrong. People are very confident in their wrong answers. So they put a bunch of examples up, like the Tom from Tom and Jerry, and how the real image is the one on the right here, where it's got like a gray belly and white hands and white feet. But they put these images that are slightly different, but then they make it look really close. So there's nothing drastic about it. But then there's all these different characters where they just change the like slight manipulations in it. And these are all the ratio of responses in this chart, which I'll link in our show notes too, which is interesting. So there was a bunch of these images. So they put R2D2 and Curious George, Fruit of the Loom, Pikachu, Volkswagen, Where's Waldo, all these different images, and they're just slightly off. And basically they're saying that most people just get it wrong just because the images are so close, you know? Mm-hmm. Like there's no real, like you could just say which one is real.
They're
and
not,
eventually
they're not confident in their choice. They're just guessing. And getting it wrong, or
so
they
a lot
are
of times
confident.
they're confident in their choice, but they say that some of the other images look familiar, and usually they get it wrong, and they're confident about that wrong answer. But it's just these slight changes, like you know, and so these are just the idea, especially for the logo ones, because that seems to be pretty prevalent, like the Fruit of the Loom one with the cornucopia or not. So this could be, you know.
Wait. What's that one?
Oh, you haven't heard that one? So there's a lot of people that say that this is the true image of the Fruit of the Loom logo.
Yeah.
Which looks right.
Yeah.
Yeah. It's actually this one on the far right where it has no plate, no cornucopia, and it's just a bundle of fruit.
No.
Yeah. So that one is the one of the more popular ones. And there's actually people who have found old tags on clothing and stuff with the cornucopia. So that one's one of the ones that like people are pretty damn sure that there's some kind of weird psychology experiment going on, you know, with this whole Mandela Effect thing. And there's obviously like the written ones like the Berenstain and Berenstain Bears. There's obviously the famous Nelson Mandela one where people thought he died in prison in the 80s. Mm-hmm. Yeah, there's all, and they do these are the ones that are popular, like the Fruit of the Loom. But then they do these ones like people didn't know.
Okay, so that's clearly their logo now, but no, dude. This is the first I'm hearing about the cornucopia one. No way.
Yeah, no, that one will send you down a rabbit hole. And there's actually people who can produce some evidence that makes you think twice about it.
Boom.
So yeah, right there. But
cornucopia found.
What if that's not even a Fruit of the Loom? What if that's a knockoff?
Nah.
But I've seen other pictures like that too, where they show different tags and stuff. And it was
what a time to be alive. I love Reddit.
Comment sections are great. But yeah, like a lot of people like this R2D2 one, a lot of people didn't know that his right leg was a different color. You know what I mean?
I thought his arm was only a different color later on one of the other movies, huh? I don't remember his. Yeah. Huh.
His leg in the original was like a silver leg.
Interesting.
Anyway, so yeah, they did a bunch of studies where they just gave people a bunch of false images.
What the heck?
Yeah, the cornucopia one is.
We need to do a deep dive on the Mandela at some point, like a whole show, and like spend time like gathering all the
examples and then talking about them. Yeah, I'm down. That'll be a good one.
That's the thing about it is like, yeah. exactly what just happened to me. Like, that's what happens. That's how I felt about the Berenstain Bears too. Like the Berenstain Bears, like
doesn't sound right.
Didn't sound right. I also remembered. I also remembered a genie movie with Sinbad.
Me too.
Yeah,
that one I am almost positive I saw a movie with Sinbad in it where he was a genie.
Yeah,
I
mean, I know there's the Shaq one.
No, I know, but I know what Shaq looked like, and I know what Sinbad looks like. In my memory, I have a clear distinction of the two.
Right.
And I just can't see how I can just be that off, and all these other people around the world are the same way.
Right.
That's crazy to me. The Sinbad one is the one that gets me the most. Like, I remember a movie.
Yeah,
and
I'm pretty sure I watched it.
Yeah, and there's
Can
actually.
I tell you anything about it? No.
There's actually like a clip of the Sinbad, like the part that's.
Do you think we're doing the same things that AIs are doing? We're hallucinating, essentially. We're getting. It's funny that you brought this up after that AI article, because like we are getting stuff confidently wrong in this case.
Right.
Like, are we all hallucinating this stuff? And if we are, like,
collective hallucinations,
why is it collective? How does that work? Why is that a thing? Why would a whole entire group of people have the same false memory? That,
you know what, and it kind of ties perfectly into a lot of the panspermia and viruses, bacteria being coming from, like, right into Chandra Wickramasinghe. Wickramasinghe.
Yeah, you pronounced it with a V.
Zinga. There's
Zinga.
a little
Zinga.
Zinga.
Such a cool name.
It is. It's fun to say. It's hard to say. It's fun to say. But yeah, he even like the idea of, like, it all kind of ties into this idea that the generative nature that we come from, like whatever we come from originally, humans and life, like there's something very weird, computer codey, otherworldly. And even if this is right, even if panspermia is right, it's still like DNA and bacteria. They have jobs, they have coding, right? So if it's just biological coding instead of synthetic coding with simulation, like it could just be that instead of a new computer program being downloaded onto the system you're operating, it's a viral code that is being implanted onto the earth, which creates the evolution that happens to change what's going on here. It implants certain different things and wipes certain groups things out, clears out areas with pandemics and this and that, and it changes the dynamics of what's going on Earth. Yeah, in the panspermic idea, and that's similar to what you would expect in a simulation theory too. Right, where the computer code, we call them viruses. If there's something that changes the code and it mutates, that is a virus, whether it's simulation or biological. Or it's like there's like a term for it, like an update while the thing is running. It's like a hot update, or there's some proper term for it, but there's this live update, like live updating, while things are running, right? Where like not everyone gets all the update info, or it's kind of like maybe it's like a peer-to-peer infrastructure where like maybe they're sending down the update, and that update is supposed to travel between everyone, but it hasn't hit everyone yet. And so therefore some people are running on different versions. Yeah. And if you believe that in the Chandra Wickramasinghe, his idea on like, if there is life anywhere, there's life everywhere, like that whole idea, then it's definitely possible that all these different, like even we are shedding, life, we're traveling in space now, and they do the swabs on the outsides. They did the swabs on their spacewalks on the outside of the windows and stuff. Well, and they're finding DNA and
you're about to dive fully into Chandra's talk.
do, yeah.
Let's take our break first, and we'll come back and we'll start going into. Probably we could do the whole show on Chandra's talk because it just is awesome.
Well, yeah, that might happen.
We'll be back in just a bit.
Cool. Welcome back from the dream world.
And as we come back from the dream world, we're going to talk about consciousness.
Yeah.
Because I got a video to share that I just remembered. It is super sick. So I just showed it to Drew while he was waiting for the
guy's name?
babies.
Anton
Petrov. He's one of these guys I watch almost all of his content. His specialty is as like a trained scientist himself. He reads all these papers that are coming out and then like distills them to YouTube videos, usually pretty short, between 10 and 20 minutes, that make it a little more digestible and like explains it to the public without dumbing it down. And he always links all the articles and all the papers.
He tries to dumb it down.
He tries, yeah, but he'll
usually give a summary. He'll go over all of the stuff as it is, and then he'll give you like a short little dumbed down summary. But
he's like one of my main sources for science news, what's happening in the cutting edge. So let's check out this video. So the title of this video is Experimental Evidence No One Expected. Is Human Consciousness Quantum After All? Which is super sick. So this essentially has to do with the idea of consciousness being generated in the brain or harnessed in the brain. This still doesn't answer that question. It still doesn't, like, this is just a step in the direction.
It's a step in the right direction to being able to ask the right questions.
Right. So basically for a long time, Roger Penrose and Stuart Hameroff have been... So Penrose put out this consciousness theory, which essentially proposed that consciousness is a quantum phenomena.
Yeah.
And no one really took him seriously because it was really just all theoretical and no evidence attached to it. And then Stuart Hameroff, as a anesthesiologist, comes in and has the discovery that certain, because we're going to skip past this part, so I'll describe this, that certain noble gases are used really frequently in anesthesia.
Yeah. And
noble gases, what's interesting about them is that they don't really react chemically. Yeah. And so there's no real explanation. Like, we know that they have effects for anesthesiology, but we don't know that
The
like
mechanism.
how they work,
Yeah,
right?
the mechanism of how they actually,
or why they work,
what they're triggering,
and specifically why these
which is weird. You would think-
unreactive noble gases that aren't chemically active. How come putting that inside your brain can shut off your consciousness? No one really had an understanding of the mechanism.
Which is weird to think that they've been doing anesthesia for a long time and didn't understand.
That, I mean,
or at least had an idea, but maybe not a full understanding of the actual mechanisms of what's going on.
You see that all the time in medicine, because in medicine, biology is so complicated. Right. There are so many pieces and parts that, and we still just don't even have a full understanding of the human body. Like we're still discovering stuff all the time, right? So, to be able to fully explain the mechanism of something like is always the goal, but you can do the science to show that something is effective and have like the statistics and the proof that it's effective without knowing the mechanism. Right.
But now they do.
So Stuart Hameroff proposes this mechanism for why these noble gases act on consciousness.
What they're actually doing.
What they're actually doing. And what he said is that they essentially go inside your brain and they interrupt, they get inside of these microtubules that are in all of your cells and all of your body. And they essentially cause the microtubules to change what frequency they vibrate at. Yeah. And anyway, so...
which effectively shuts down their communication.
Right.
Which is what they're thinking is the link between that and consciousness.
Yeah, so let's hear his... This is like, he's going to summarize the updated like Penrose and Hameroff theory, and then he'll give like a really basic description of it. And then we'll talk a little bit about the actual experiment that was done recently.
But it didn't stop Penrose and Hameroff, and they eventually proposed a new concept. They refer to it as orchestrated objective reduction. One of those 20 propositions that try to explain consciousness, but this time through quantum physics, and specifically quantum effects produced inside these microtubules that can sometimes be disrupted by things like anesthesia, as proposed by Hameroff, but overall relies on three main principles. First, these microtubules produce the quantum states, and they're able to produce this because they form these unusual crystalline structures that can somehow produce quantum states inside. It's not really well explained how, but that's beside the point. Second, anesthesia, any anesthesia, is able to affect these quantum states and disrupt them, thus causing unconsciousness. With the third principle being somewhat unusual, it actually relates to quantum states proposed by Penrose, because here it states that gravity also plays a role, and specifically because of the mass interaction, here gravity usually causes the natural collapse of these quantum states, and thus provides consciousness. So yeah, all of this might sound super complicated, and it really is, but if I were to give you a 5-second explanation, it's basically as follows. Brains contain microtubules. Microtubules form complex crystalline structures that can somehow produce quantum states inside of them. Those quantum states create these really large quantum waves inside the brain that collapse for various external reasons that somehow leads to the idea of consciousness. Yeah, sounds kind of eccentric when you put it this way, right? And that's of course what most scientists kind of said. And pretty much everyone ignored this, except for maybe a few scientists, until relatively recently, and specifically...
Yeah, so then I'll skip forward to where he's talking about the study. But yeah, so that's the basic explanation of their hypothesis for this, right? So there's reasons that people were ignoring this is because they didn't have the evidence to like link it all together. Yeah. So then these two papers that he's going to cover come up, and one of them is going to prove that these microtubules are affected by anesthetics. And then the other one is going to prove that these microtubules do, in fact, exhibit quantum effects. Right. So let's...
especially with the observed like change in the frequency, like that shows that there's some kind of...
Well, that was part of his hypothesis earlier. Yeah. No one had actually observed that.
Right.
Yeah, so here's this.
prove something entirely different. And so in one of the experiments in 2023, the scientists wanted to find out one simple thing. Can anesthetics affect microtubules directly, thus possibly providing evidence that there might be something about them in terms of consciousness? Here's actually a physical picture of microtubules inside a typical cell. And here's another picture of different cells connected together and microtubules shown in green. And so for this particular experiment, the scientists took microtubules and they basically made them glow because a lot of them do display fluorescence. But then they decided to test something about this fluorescence. They added certain anesthetics into those microtubules and it surprisingly changed the way they glow. In other words, they actually discovered that a lot of fluorescence seems to have a substantial delay when microtubules are mixed with anesthetics such as, for example, xenon. In this case, the effect is actually really small. The actual delay was only about 20% or so, but it provided important evidence that there is a connection between anesthesia and microtubules.
So yeah, that experiment is talking about the microtubules actually responding to like noble gases, right?
Right. Showed the interaction between it.
Yeah. So before that, that was all just part of their hypothesis, and when it actually showed that these things can actually have an effect on the microtubules. So now one piece of evidence has come in. We know that they can have an effect.
Right.
So then the second study that he is covering here, this goes into the quantum part of it.
These effects so far are quantum in nature. And that's until we come to this recent paper that as always you can find in the description below. And I guess in some sense, if you watch this whole video, you can probably understand what this title says. Here they used a mega network of tryptophan, or basically once again microtubules, in order to provide first ever evidence for quantum effects. And the reasoning behind the study was somewhat unusual. Here the researchers once again realized that this is a kind of a crystalline structure. A crystal-like biological structure that makes microtubules a very attractive candidate for all sorts of quantum entanglement. And this idea has been previously explored in other papers, but never physically proven. And so here, by using microtubules that you can technically buy online from a lot of different biological companies, the researchers performed a super simple experiment. They used a more complex arrangement of these microtubules and basically made them fluoresce. By shining the UV light, these microtubules started to emit light back. But here, because of the arrangement and because of the structure, they actually started producing superradiance, very likely caused by the collective interaction inside these arrangements, which results in the production of light as a kind of a high-intensity pulse, different from what's usually expected in classical physics. But this is only something that happens when these molecules are arranged in symmetrical networks, kind of similar to what we usually find in various cells. If you just take a simple tryptophan molecule, or just a few of them, without a specific arrangement, they don't do any of this. And so this unusual quantum effect that produces stronger fluorescence has been now physically proven to exist inside microtubule structures. And by demonstrating that microtubules can indeed produce quantum effects, it creates a kind of an implication for a lot of studies of consciousness. Now,
right. So,
yeah, it's crazy to think that like at that scale, right? So these are, and they're these microtubules are found all over our body, like everywhere,
right?
And they create.
They're one of the main
structures
things that can form these crazy long chains that can build structure in our cells.
And like it's talking about like under certain light, it can shine a light. It's like makes you think of like the analogy of like our consciousness being a light, and that could be where it stems from, is like this collection of.
Yeah, I mean, I don't know that they're the quote unquote quantum, like, so let's say the microtubules do have to do with consciousness, right? This study just showed one quantum effect that we now know that they have, right? Which is that because tryptophan chains, or tryptophan itself, can fluoresce.
Yeah.
If you strike it with the right amount, with the right type of ultraviolet light, it will start fluorescing.
Yeah.
And
in certain configurations, it has to be like complex configurations. It couldn't just be like a couple of them.
No, they'll fluoresce. But what makes them super radiant, that's the quantum effect. Fluorescing is normal physics, but displaying super radiance, that's something that is a quantum effect.
Yeah, you don't get the quantum effect unless they're in these structures.
It's like the difference between a conductor and a superconductor, right? Like any copper wire is a conductor, but to get a superconductor, that's a quantum effect. You need to set things up in a very specific way in order for it to exhibit those quantum behaviors.
Yeah.
Right? Like bringing stuff down to absolute zero. Or as close to it as we can go. So in the same way, what this study is, all it's proving is that microtubules exhibit quantum effects. In the study, it's showing it with super radiance. That doesn't mean that super radiance has anything to do with how they work in our body or the types of quantum effects if they tie into our biology or consciousness. It doesn't mean that radiance has anything to do with it. Sure. But it does prove that they exhibit quantum effects. So if they exhibit this quantum effect, we don't know the extent of the quantum effects that could come out of it.
What the implications are for these early indications. Yeah.
Right. So the tryptophan can fluoresce, but in these long chains, then it can super fluoresce.
Yeah.
That's when it can become super radiant.
Yeah.
And emit way more light than it should be able to under normal physical laws.
And then they were talking about, I don't know if we played the clip for it, but about the effect that they're saying gravity has on collapsing the wave function when it becomes super radiant.
Yeah, so
they're having the quantum
that's
effect.
Part of Penrose's original theory for this is that the brain is, somehow creating all these quantum states, and that gravity is involved in collapsing those quantum states.
Yeah.
Which, maybe, but that kind of sounds like a way to still have like everything mechanistic.
I was going to say, because
it sounds like there's lots of, once we get to the point, like if we can actually connect the microtubules to consciousness, because this doesn't fully do that yet. It just suggests it pretty heavily, right? Because now we know that microtubules react to anesthetics, and now we know they have quantum effects.
And so
we still have to show that the microtubules actually have anything to do with consciousness, though.
But we do know that it can either suppress or I guess break the connection between consciousness and the physical reality, because they're using it for anesthesia, which means that you're not feeling anything, you're not conscious, you're not awake, you're not experiencing your physical body like you were before.
Right.
So that's where the link to consciousness is.
Right.
We just don't know the relationship of what these structures and what the tryptophan have to actual end state, knowing what consciousness is.
Right. But now,
but this is a piece of it.
It's a big piece though, because it gives direct evidence that this is something to look at.
Right.
And if it's not this, then we still need to find other things that are affected by the anesthetics.
So back to the idea, or the what we were talking about with the wave function, the quantum state, right? We know from like the quantum physics that the wave function collapses during, like when there's an observer. And like what I was kind of mentioning outside a little bit, we were watching the video. It's like it.
Yeah, a lot of scientists will have an issue with you describing it that way, even though that language originally came from science. Nowadays, when you hear people talk about quantum effects, they will specifically try to avoid the term observer, and they will use the term measurement.
Okay.
Because
either way,
they will tell you that's what they mean. They're not saying that actually someone has to look at it.
Right, but the measurement still has to take place, which we don't like. As far as like what that measurement is, who's measuring it, what's the measurement being taken
Right.
by, that's an
Right.
observer. So
Right.
like there has to be somebody making the measurement,
And
unless
they
it's a process.
Well, yeah, it could be some sort of physical process that depends on the object being in one of those quantum
So it's always
superposition states.
measuring.
And so it like as soon as something goes to chemically interact with it in such a way that it needs it to be in one of those positions,
Yeah.
that could be the measurement too.
Right.
Right. And so maybe it's in a fuzzy cloud until some other fuzzy cloud comes near and they want to interact, and then they both snap into place. But
That could be a description of all of physical reality right there, ladies and gentlemen. It's just we're all just moving through a quantum field, and everything's just attaching and assembling in the right order
yeah,
as needed.
so this is pretty
Slight
exciting.
changes.
Like this could be like a little crack in the dam of science of, you know, if people keep like researching down this path, like I don't know what it's going to come up with, but whatever it's going to come up with is going to be quite interesting.
Super interesting. Yeah.
Yeah. I mean, it looks like it does have direct implications on consciousness, which is great.
It's exciting to get any kind of, idea of what's going on in the old noggin.
Right. Right.
We have no idea.
Dude. Yeah.
We have no idea. I mean, there's so
And to my
many-
understanding, we still don't even know, like back on the quantum physics side, like we don't, like, I don't think we have an understanding of why a measurement causes a collapse, or the mechanism for how a measurement causes a collapse.
I don't think so.
I think they just know that it does, and they just go with that. But I could be totally wrong. And if I'm wrong, please let me know and point me in a direction, because I love to learn about it.
Yeah, I don't remember.
In fact, maybe we should ask ChatGPT.
Sure. See what they hallucinate.
Yeah, let's see what ChatGPT can hallucinate for us on this topic. ChatGPT, can you explain in quantum physics when a quantum wave function collapses, do we have an understanding of why or how, like the mechanism by which a wave function collapse happens, or do we just know that it does happen and we are studying around it? Do we actually have an explanation of the mechanism of collapse, or why a measurement would force a collapse?
In quantum physics, the collapse of the wave function is a central yet enigmatic concept. When we perform a measurement on a quantum system, the wave function, which describes a superposition of all possible states, seemingly collapses to a single state. This collapse is what we observe as the outcome of the measurement. However, we do not fully understand the exact mechanism behind this collapse. There are several interpretations and theories, but no consensus. Some of the prominent interpretations include: 1, the Copenhagen interpretation, which suggests that the wave function collapse is a fundamental part of quantum mechanics, triggered by measurement or observation. 2, the many worlds interpretation, where the wave function never collapses. Instead, every possible outcome of a measurement happens in some branch of the universe. 3, decoherence theory, which explains how interactions with the environment can lead to the appearance of wave function collapse, although the overall system remains in a superposition. These interpretations address different aspects of the measurement problem, but do not provide a definitive mechanism for wave function collapse. Essentially, we know it happens and have various ways to model and interpret it, but the underlying why and how remain open questions in the field.
So no.
Right. Okay. I was right. That was what I thought. But I always, like, when I start talking about stuff confidently, I'm like, I don't want to be a ChatGPT hallucinating to all of you guys live on the podcast. But my understanding is that, and
all that is going to happen is you're going to create the next Mandela effect.
Yeah. Right. So, We're actually pretty close to our second break, and we still haven't talked about the Cosmic Summit. So
I'm
why
sure
don't
that'll be our
we?
whole next segment then.
Yeah,
We're
let's
gonna have to
let's dive deep into that. And the reason I wanted to bring this up because I think we
I
can
think it's gonna
combine.
kind of circle around.
Yeah, I think we can circle this together with
Yeah,
some of Chandra's
100%.
topics. So we will be back in just a few minutes. Welcome back.
All right, so Chandra Wickramasinghe.
So his talk is like obviously the same topic he spent most of his career on, which is panspermia. And it was awesome. Every time I watch it, I'm just like, I want to go read Chandra books. And I still haven't yet, but I bought one. So now I will be reading.
Sick.
Yeah. Trying to recall where he started out.
So a lot of what he started with was like the idea of like the complexities of like life having to grown, like have evolved from nothing, from like just being here on Earth with no intervention.
Right. So he's talking about how essentially what we have, today now found is that the instant that the Earth was habitable and complex organic compounds could survive on the Earth is the instant we find life.
Yeah.
Plus or minus a few hundred or couple dozen million years, like not a lot. Like,
so you would have to assume that it is like dormant under conditions that it cannot survive, or
under
some sort of
under the standard theory, you're assuming that like, I guess life was not that hard to create. But the thing is, like, even the earliest life, like, it is incredibly complex now that we have this understanding of biology, right? Like, the DNA, like, has been around for all of it, as far as we know. And so I have yet to see, like, anyone in like, the origin of life science, like, adequately show that, like, or even have like a real like convincing narrative for how DNA came to be. What
was the building blocks for it? Like what what was the first spark that allowed it if it wasn't able to be before?
Right.
Because it wasn't like as soon as the Earth formed and cooled a little bit that it started. It was way after that, millions of years.
It was right when the Earth cooled that we find life.
Yeah,
pretty much. Like
that whole time period, you know.
I believe it's somewhere in Australia is like there's some outcroppings of rock that are from that old, like that are that old. They go all the way back to when the Earth first cooled, and like that there, and even there they found like signs of life, which is crazy. So yeah, and then he talks about.
So and then he goes to like his idea basically. He tells like the alternative to the terrestrial origin of life against the incredible odds is the concept of panspermia, life's origin as a one-off or a near miraculous cosmic event, and delivery to planets by the agency of comets.
Right.
So in his idea, and him and Sir Fred Hoyle, his mentor, wrote the books on their ideas and stuff. They literally wrote the book on this. No, I'm just kidding. But they talked about how comets, and if you look out in the Milky Way and you see like the dark patches, if you get a good view of it, you see the dark patches in there. They describe those as the dust clouds,
the nebula.
Yeah, and that comets, and maybe some asteroids. I don't think the asteroids though. I think they specifically say comets, and this space dust are basically carriers. They're harbingers of life and bacteria, and like now with like the recent finds of like tardigrades and all of these like complex life forms that can survive in space and survive in harsh climates, could be piggybacking off
so I think what we're finding
comets.
I think what we're finding is that what happens, not everything can survive in space, but a lot of microbes, when they're exposed to the extremes of space, they just go dormant. They essentially sleep. And that all you have to do is add heat and water, and they just start ticking again.
Yep. And replicating and all the things.
Which
tells you that it's possible that life can be, like, panspermia is a real thing. Whether it's happened here or is what happened here is the thing that they're debating on, right?
Yeah. So, and then he goes into some of the evidence, and he talks about how they've done. He showed a bunch of graphs of spectrum analyzing, analysis of nebulas. And the kicker of it is, like, the real, like, impressive part of it is that they had a prediction curve of, like,
lab bacteria.
Right. So, like, what was the bacteria they chose?
I think it was E. coli.
Yeah. They said, like, this is the spectra for E. coli, and they showed, like, you know, a particular curve. And then they did the spectra analysis on the nebula.
The space clouds and space dust.
They dropped those data points against the predicted curve, and it's almost a perfect match.
With a few one-offs,
Right.
Which showed to
and
them.
He had multiple examples of this from different observations of different things, like comets and nebula and even some of the
Halley's
exoplanets
Comet was the big one,
with
and
the
then
new James Webb
the new
data.
one. Yeah, the new one, it was April 2024. They found dimethyl sulfide, a chemical known to be created, only be created by phytoplankton on Earth. in the atmosphere of the exoplanet K2-186 at the distance of 120 light years away from us.
Right.
So they found this on a watery planet, this K2-186. It's an exoplanet, and it has an atmosphere, and we only know phytoplankton to be creating this element, which is a life form. Mm-hmm. So based on that evidence, that's the new stuff coming out too. Like that's the 2024.
Right.
But all these new telescopes are going to be shedding more and more light.
And you could throw skepticism at that. Obviously, people are going to, and they're going to say, oh, well, just because that's the only way we know how it's made doesn't mean that's the only way it can be made. Sure. And there's going to be some exotic circumstances in that atmosphere that are responsible for, what was it, dimethyl sulfide?
Yeah. Yeah, I mean, this is just one exoplanet too, you know what I mean? Like the Kepler telescope led to the discovery that there's 140 billion habitable exoplanets in the Milky Way alone. Mm-hmm. And the average separation is only 4 light years.
Right. I remember that part stood out to me when he did the math on like the amount of habitable worlds and then like ran the distribution on it. Yeah. Mm-hmm. And on average, habitable worlds are only 4 light years apart.
Right.
Which is crazy.
So the idea that comets could be bouncing off of these and going, through these and even taking pieces from there and transferring to the next place.
We know that comets move through in interstellar space. I was going to say intra, but that would be within the solar system.
Right. They don't need to be within a
system. If they come in, they can get kicked out by their star and end up leaving their whatever star system
instead of just staying on an orbital path. Yeah.
And then he had this other really cool graphic because you're right. He talked about Halley's Comet.
I have the graphic here.
You do?
It's a screenshot, but
the one of it orbiting the sun and its tail spitting out across Earth's orbital. Is that what you're talking about?
No.
Okay, so yeah, this graphic he had, it was a little animation, and he showed a comet that's orbiting around the star.
Like that one. We'll have to grab it if we can.
So I remember at some point I didn't know this, but like maybe so if you don't know this, you could be forgiven. But when you look at a comet and its tail, you think, oh, that tail is indication of what direction it's going, but it's not. The tail isn't trailing behind the comet. The tail is being kicked off in the opposite direction of the star. So if a comet is way out in our deep solar system, like way out at the Oort cloud or whatever, and then it comes in, while it's out there at the Oort cloud, it's like frozen solid. But then it comes in, and once it gets in towards this inner solar system, it starts getting warmed up. And when it starts getting warmed up,
blasting off.
The solar wind will blast at it, and it will push particulate matter out in the opposite direction of the sun from the comet. So as it travels around the comet, the tail is always pointed away from the sun. Mm-hmm. So the tail is an indication of where it's traveled. It's not like an actual tail.
Right.
It's
showing its relation to the.
It's more like a shadow, right?
Yeah. Right. That's a great way to describe it.
And so because it's that way, as it comes in through the inner solar system and then whips around the sun and then goes back out, that tail is being pointed out in the direction of the other planet's orbits.
Blasting
whatever matter is being blasted off of it. And then these planets are orbiting around. That comet debris is now in the path of the planet, and so we're going to orbit through that, and whatever particulate matter came from that comet is going to fall down in our atmosphere.
Yeah. There you go.
And so showing with the spectrograms that there is evidence for life and
specifically
organic material in these comet tails.
Yep.
And then knowing that we're essentially driving through the tails of these comets all the time.
So it was funny. He had a few slides that made me laugh. In October 2015, a French group of radio astronomers reported the discovery of a profuse flux of ethyl alcohol and a sugar in the tail of a comet Lovejoy. And then the next slide is equal to 500 bottles of wine per second. Clearly products of fermentation. And then it's got this picture of the space dust with the cocktail, like a neon cocktail sign superimposed. It's funny. But then quickly after that, he shifts to talking about the viruses.
Yeah.
And the bacteria, and not just the particles that are coming off, but what is within. So on Earth, 10 million viruses have recently been counted in a single drop of seawater. Each virus is a genetic program that can be inserted into cells. So that was kind of his idea of like the effectiveness of them. So they're basically genetically programmed to.
Amy sent me a podcast a couple years back. I think it was during this whole like COVID thing. And it was some doctor, and he was talking about how viruses communicate genetic material. And at the time I was like, that makes sense, but I never hear anyone talk about this, like anyone. So like I had a hard time accepting it. But then when I hear Chandra talk about it, it just makes all the sense, because he's right. Like when there's this many viruses, we are literally every moment of every day of our lives, we are in contact with just millions and millions of viruses. They're constantly coming in and out of our body. And when we hear the term virus, we think disease, we think getting sick, right?
Yeah.
But not, in fact, a tiny amount of the population of viruses actually has that effect on your body.
Right.
Not all of them make you sick. But what they do when they enter your body is they can go in and they can end up rewriting bits of your genetic code.
Yeah, they basically implant whatever genetic, like they. What he was talking about too when he connected this whole idea was that they're a great transmitter of genes between different species on Earth. Right. So like any species, all the different species that it's come in contact with, it's like almost storing bits of the code within it, and that's how it can manipulate and change when it goes through different hosts.
Yeah.
Like when you have one virus go through, a certain population of animal, and it changes its genetic structure, and it can communicate that to the next. And some of those can't be combined. And that's where you get the viral stuff.
And the impression I got from Chandra, and I don't know if this is true because I haven't looked into it yet, but I want to now, which is the idea that not only can the viruses write genetic code, but they can actually read genetic code too.
Oh, right.
That's the impression I got. I don't know that he specifically said that, but if that's true, then that would essentially give a mechanism to if one species has an evolution in one particular subsystem, and then some virus comes and picks up that gene and then goes out and distributes it to all this life elsewhere in Earth. Like we're talking like essentially communal evolution now,
right? Not
just evolution by natural selection, but like once a species figures out some sort of adaptive change, if that adaptation gets picked up by a virus and then spread out to other species, your species figuring something out can help other species figure stuff out.
Right. Yeah, and that could be why we saw the big boom in species, right? And the big the big boom in even just primates, right? This missing link type idea of it kind of help make sense of Darwin's evolution.
Yeah.
When you think of these viruses being the thing that kind of helps the evolution happen. So you got viruses coming in, and say one species is able to use their brain differently. One of these primates, and then, like you're saying, it picked it up via virus and transmitted to all the other primates and of different species, or not primates, but all the different. I guess it would be even before then, maybe. Because I'm thinking of like Neanderthals and like all the different species of Homo sapiens.
Right.
And how they all could have had all their evolution was the same way, but like certain attributes transmitted via virus and stuff,
That's an interesting idea.
And obviously it would have more effect on early life, right? Like single celled and like early stuff.
Unless it's some crazy giant virus pulling an entire gene, like it's like those are long chains. Like maybe it's more like small little bits,
Right. But then that's still such a hard thing to expect evolution to.
Yeah. So that's another part of his talk is he addresses evolution itself, and he talks about the weaknesses of evolution as far as describing, the speed at which life has developed.
Right. Yeah, they talk about the Cambrian
explosion.
Cambrian explosion jump.
Yeah, and so essentially the theory is that, this organic material and viruses are raining down on us at all times from space. And the way they measured this was they send some of these like super high altitude balloons like way up into the stratosphere where there is nothing other than just little tiny like little wisps of our atmosphere are still there, right? But there's no bacteria or anything up there. And so they send them up there, and then they do these sample collections, and they're finding all of this organic material, bacteria, all sorts of stuff falling down and
collecting into
And then I think he did an estimate for like how much biological material is falling down on Earth per day, and it was like tons of material. I forget.
So this is outside of our atmosphere?
Yeah. So this is just stuff falling into our atmosphere from space. There's tons of it that falls down every day, and it's just like bacteria and viruses and stuff. And you know what it makes me think about? It makes me think of the Charles Fort and the Book of the Damned.
Oh, really?
Yeah. If you haven't heard of that book, check out the Brothers of the Serpent podcast. I'll leave a link in the description. They have a whole series on Charles Fort and the Book of the Damned. It's something I would like to do here, but I don't want to just copy their podcast directly. So, but I have yet to read it, and I think it would be fun to read it. But that book is, when it says the Book of the Damned, it has nothing to do with religion. When he's talking about that is damned is scientific evidence. And essentially the entire book is about legitimate science and scientific evidence that has been done and found that goes against the mainstream explanation of things to the point where it ends up just getting shelved. It's
those are the damned
evidence. That's the damned.
Even though it might have future revelations to be had on some of these.
Yeah, and so it's kind of like the story of how we discovered meteors, like how farmers and people had been witnessing them for a long time and keep talking to scientists and telling them, hey, this thing fell out of the sky, this rock fell out of the sky onto my farm. And then the scientists at the time, they were like, no, we are studying the laws of physics, and
rocks
there's
don't
a
fly.
thing called gravity.
Yeah.
There's no rocks in the sky, therefore no rocks fell out of the sky onto your farm. I'm sorry. That is against science.
Right.
Until later when
they discovered. Yeah.
Right. So in a similar way, there's all this crazy stuff that Charles Fort has documented
stuff,
in his book. And it's weird shit. weird gelatinous substances falling out of the sky, fish or frogs falling out of the sky, stuff that can only be described as blood falling out of the sky. And these things still happen to this day. It was only a few years ago that there was one of these falls in India that was said to be blood. But I think as it got analyzed and it wasn't. But
I was going to say, because I know that they attribute a lot of this to like weather phenomena, like tornadoes or
right.
like quick, like what do they call them?
Like hurricanes or typhoons or things that can like pick up material and like throw it up in the upper atmosphere.
Yeah.
And for it to come down later. But the problem with that, with Charles Fort in the Book of the Damned, because he addresses that, is that how come it's just fish? Like, why isn't it fish and other species?
Right.
Like, why is it just one particular species of this? Or, you know, like, how does it sort everything so that it's just all the fish that it happened to pick up that happened to land on this random farm in the middle of Europe?
I mean, you could attribute some of that to like where the thing happened. Like if it happened over the ocean where there's a school of fish and they're all jumping,
right?
Like I could wisp
but there
them up
should
into
be
the
more
air
than just like, you know, like.
Yeah, no, I understand that.
It's not a sorting mechanism, right? It's a random occurrence. Like, so there should be no way to
and you should be able to detect and find evidence for those things happening nearby when they're falling down. Like it should be pretty obvious that there was a tornado last week or there was a typhoon last, you know.
Yeah. The other thing that Chandra's talk makes me think of is Owaspy, because in Owaspy, and this was written in the 1800s by channeling, right? And he talked about how, or the Owaspy talks about how there are these nebula all throughout space and they have everything that everyone needs, like all the different planets. And so the process of life coming to a planet is just the process of it moving through the galaxy, going through different areas that have all the different components that kickstart things.
Yeah. And having the planet itself be in a state that it can support life.
Right.
Like it needs to be in
so like as you're traveling through, once you're in a habitable zone, once your planet is cooled down and able to be lived upon, you're going to travel through these clouds of stuff. That stuff's going to fall down and it's going to start metabolizing.
Yeah.
And
I mean, and
multiplying.
That's if you believe that the only type of life is the type of life we have, you know?
Right.
If you think about the vastness of the universe. And,
according to this theory, according to Chandra's theory, like we are all part of one giant universal
genome in a sense.
Family tree, right? Like talk about the tree of evolution. We're talking about a universal tree of evolution now.
Right. Yeah, we're talking about parts sharing and changing, and like eventually, if you believe in evolution, even if you believe in the panspermia, we will evolve based on the types of viruses or bacteria that come in and can change our genetic code, and eventually we change over time, and maybe the planet changes too, so the way it can support life changes, which changes the code on top of the viruses having effect, you know?
Yeah.
It transmits those changes in the code, and then it goes off and sends that information to the next planet that it goes and hits or whatever.
And, you know, if gravity is involved, remember the video we... I'm skipping topics in my head here, but... I wanted to tie it back together to the video we watched about consciousness, because like when you start realizing that consciousness, like how complex it is, if it really is taking advantage of quantum phenomena,
right?
If every cell has these microtubules that are exerting quantum phenomena in them, like it starts to strain credulity for it to have evolved on Earth in like a handful of millions of years, like right after it cooled down. especially when like no one has been able to recreate,
those conditions.
There's people like origin of life scientists. There was a famous breakthrough, I think it was back in the 90s, where they were able to just like, they talk about the like chemical soup or whatever.
Right, the primordial soup.
The primordial soup, that's the
Earth.
term of early Earth, and that like there was all these lightning strikes and all this energy, and the moon was closer, causing the ocean tides to be like this crazy churning,
leaving these pools of warm water and
right.
Yeah.
And so they try to like emulate those conditions in the lab, and they were able to get some of the basic organic molecules to build into more complex organic molecules, which is a huge step for the idea of terrestrial evolution.
Sure.
But it falls short because that's all they weren't able to get like full amino acids. They weren't able to get like full protein chains. They weren't able to get us a jumpstart cell out of nowhere.
You know what they need to do is redo that and spray it with a cosmic dust and then shoot some bacteria and viruses and stuff and change the genetic code and do that over time and watch it change as you introduce new stuff, and then you maybe be able to prove panspermia.
Or send a satellite in orbit and like have it open up to space to catch whatever is around there in space, and then bring it back in. Yeah. So yeah, the other thing he talks about, and I think we talked about this early on in the show, but like he talks about how the International Space Station has had to have the windows cleaned multiple times because it builds up this film.
Yeah, I was going to bring that up
because sample that, and it's full of life.
Yeah,
full of bacteria.
Which, I mean, if they're really floating in space, it's airtight. So there ain't anything coming. I mean, yes, you could say it hitched a ride from the Earth.
I mean, it is low Earth orbit, and technically low Earth orbit is still in the atmosphere. It's in the very upper stretches of the atmosphere. Yeah. But things like the International Space Station can be impacted, like when a solar storm hits that causes the atmosphere to expand. It can cause extra drag on those things, causing them to lose altitude. And that's why they have to constantly, they have to have fuel to keep them in the proper orbit.
Right.
But anyway, we're ready for another break here. So let's do that, and then we'll talk more.
Cosmic Summit.
We can,
Wickramasinghe.
Wickramasinghe. We can talk more about him and some of the other stuff we heard. So we'll be back in just a bit.
Cobwebs, such a fitting name. I mean, you've got to be labeling these in real time.
Why is this one so fitting? Well, because
Cobwebs
what
of
we
space
just
and
talked
time.
about, yeah. We didn't talk about that part on the podcast.
No. But yeah, as soon as we cut, I found a little picture and it said what is it?
It's the largest. It's the largest sky survey that spectroscopic baryon oscillation spectroscopic survey. It's an effort to map galaxies and quasars in the early universe, and
it's like cosmic webbing,
right? So if you've ever watched like cosmology videos or anything where they start zooming out from even the galactic scale into these superclusters that the galaxies form, and then you even zoom out from that, and then you realize that these superclusters they all kind of form into these like thread-like, cobweb-like shapes.
Where there's big gaps in between them, but they have these threads.
They call them the super voids or cosmic voids, yeah.
Yeah, where they all sort of connect in a sense that you could imagine connecting once you're zoomed out enough.
Right.
Like webs, like little threads that leave this pattern of voids.
So apparently there's, a new survey that just did the biggest one and found the biggest structure ever recorded yet so far.
So that's what I was referring to when I said cobwebs.
For sure. We still nerd out even during the breaks.
Yeah, we do. A lot of times we're like, damn, we should have been recording that.
Yeah, I try to catch it while it's happening and be like, stop, save it.
So to go back a little bit to the microbial life in space and like the, panspermia and stuff that Chandra talks about. So he says he proposes that some pandemics on Earth might have extraterrestrial origins brought to our planet by comets and space dust. Mm-hmm. So not only these genetic possibilities of it having seeded life, but even now, like there's still threats that are coming to Earth via these pandemics or viruses and bacteria.
Right. With the viruses coming, right? Like, again, we already talked about earlier, like a certain percentage of those are going to be the type that can get us sick. And
it's non-terrestrial.
Right.
So we don't know what the effects would be.
It makes a ton of sense that it could start pandemics sort of out of nowhere.
And you know what it, could also indicate is like imagine being on a world that's, able to support life, maybe not large life like us, but early Earth, right? And then you get these viruses that come in and can infect or change or disrupt the life that's already there.
Yeah.
As well as the conditions being erratic and changing, and you have to adapt. That could lead to an evolution or a step.
Right.
Depending on, like, there's a certain branch that is trying this thing to survive better or whatever, and then this virus comes in and it basically super replicates because the virus can get the genetic code and it goes to the next thing, and they're all evolving together just by being infected by these viruses.
Yeah. What's cool about this whole theory is it sort of... So, there's this kind of like, there's different takes in sci-fi as to like what alien life would be like.
Right.
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 And there's those who portray alien life as like all, when we go out in space, like in the Star Wars universe, it's a bunch of aliens that look like humans, but maybe some extra features or different color skin, but they're all humanoid. Except for, I guess, Jabba. He's a big slug.
Human-like.
But then there's other sci-fi that's more like, say, like The Arrival. You ever watch that?
Yeah, with the octopus
yeah, like the squid things. Yeah.
That's a good movie.
And in a certain sense, like that's more realistic, right? Because if life separately evolves, right? If the terrestrial theory is true, then whatever life is out there would have also evolved terrestrially on its own planet with its own history and its own DNA code and its own, like everything, even the origin would be different, would be right?
Completely different, yeah.
It may not even use DNA, might have a different mechanism.
Structure, yeah.
Maybe it's a triple helix instead of a double helix. Like, who knows?
Yeah.
Right? But if Chandra is right, then most likely the building blocks of life came from outer space. And if that's the case, then probably life everywhere in the universe uses the same sort of DNA system that we do. And therefore, there's good and bad to that, because if we do end up flying somewhere and exploring another planet, like if it's another planet that had a different terrestrial origin, then in some sense, you don't have to be necessarily quite as afraid of like microbes and stuff on that planet, because they may not even be able to act on you, right? Whereas if everything does come from the same source, then, you know, you go to Mars, you're going to get the Martian flu, right?
Right. Yeah.
So.
True. We don't know.
Right. It's interesting.
Very
idea.
Interesting.
Did you have, what else did you take notes on of him, or is that about it?
It's most of what I got, yeah. Okay. So I don't know if there
was another thing he hit on that I can't even get it close enough to the top of my head to like describe it to you that I wanted to touch on, but.
So it was really just his work in general inspired a lot of science fiction, like we talked about earlier, and like he inspired even people like Arthur C. Clarke, and a lot of his works, and a lot of his books and stuff.
Yeah, he was homies with them, right?
Yeah, they were friends, but he like their ideas are what kind of sparked a lot of his creative endeavors.
So. I guess since we're in the last segment here, we can talk a little bit about another speaker then. Yeah. Did you watch the Malcom one?
I did.
Okay.
I did.
On the main day, or the day one, right?
The first, yeah.
Day one main stage?
Yep.
Yeah, so his talk, I think he was slotted for an hour and a half, but he kind of brought up a bunch of guests with him.
Yeah, he did bring a lot of people up. To kind of, seemed like for a little while he was trying to, just
let's set the stage here since we're switching topics. So if anyone isn't familiar with Malcom Bendall, he is the inventor of the thunderstorm generator, which I'll leave a link to. His thunderstorm generator is a way of modifying existing combustion engines in such a way as to make them burn clean and produce extra energy output.
That's right. The clean burning engine.
Yeah.
The process was fascinating that he was describing.
And there's a lot of claims like that there may be some sort of transmutation of elements happening, because once his thing is connected to an engine, the exhaust output changes, right? So instead of all this carbon dioxide, carbon monoxide, and all these like crazy chemicals and like reduced oxygen due to a bunch of it having been burned in the explosion and inside your engine, what comes out is essentially
different element,
atmospheric levels of gas, atmospheric levels of oxygen, atmospheric levels of carbon. The carbon dioxide drop back down to normal atmospheric levels. The carbon monoxide, I think, is not even there or barely registers. Anyway, Malcom Bendall is this guy who had this whole like drama thing going on. So the way this all started was Randall and Graham Hancock were on the Joe Rogan show, and they had talked ahead of the show about not talking about Malcom Bendall and his thunderstorm generator. But during the show, Joe asked Randall about it, and so Randall did talk about it.
Graham kind of poked him a bit, but that's here or there.
He tried to like be quick and move off it.
He tried. But Joe was fascinated and just kept poking.
So they talked about it for a while, and then everyone was like, "What? What's this all about?" So then later on, Joe sets up a show with this guy, with Randall, and also George Howard, the organizer of the Cosmic Summit.
So apparently it was just supposed to be with Randall, but then like a few days before, Randall drove up there with George Howard and Malcom Bendall. And he was like, "Hey, I got these guys who know more about it and could give you more detail. Would you mind if I bring them on?"
Right. And so they go on to do this podcast, but apparently, according to Randall, who's talked about what happened on it, he said that essentially the whole thing devolved into Jamie, who found some stuff online about Malcom Bendall, and that, calls his character into question.
Right.
The entire podcast became like them grilling Malcolm about his past and his credibility, rather than what Randall was hoping for, which was just focusing on the science,
technology, and
the technology.
Yeah, which Joe, there's definitely been times where Joe gets like stuck on the thing and just won't get off it.
Right.
And
so then later,
Randall kept trying to get it off the topic, but Joe kept bringing it back up. And so
later, Randall did some podcasts about it, and then Malcom Bendall open sourced it. He's got everything online, like you can check it out. He's got the plans, you can build it if you're like the engineer type. And I've seen a bunch of videos with, pretty credible claims. Apparently there's one running at a power station in the UK right now.
It's supposed to just like lower emissions, right? Like that's kind of the idea. It's just,
I think it's also about increasing efficiency,
the efficiency,
which is huge.
Yeah.
If you can get more mileage and less, exhaust, then that's
a huge win.
Right.
Win-win, yeah.
Anyway, so, and he also has other claims attached to it, like saying that at some point, once you've been running off the gasoline, like the gas engine is just to get the thunderstorm generator going. Once it's going, he claims that you can kind of rely on that reaction rather than the engine for power. So
eventually you get to a point where the engine no longer needs to be on and it can just self-sufficiently keep itself going.
Right. And so he gave a presentation. Every time I've seen Malcolm present, he's
not a great presenter.
He's not a great presenter.
Yeah. He's not a great presenter. He does, in fact, like start off saying, "I'm not a teacher. There's plenty of people here that I work with that are great at communicating this stuff."
Right.
And he brought those people up on stage. It's kind of where we were going at originally. He brought some people up to talk a little bit more about the specific stuff and kind of lend some
his
credibility.
My understanding of his general explanation of what's going on with this thing is that it's using vortexes and plasmoids. Okay,
Right.
So essentially what this thing is it's like a tube within a tube that connects to like a ball within a ball within a ball. And the tubes within the tubes, one of them is taking in the hot air from the exhaust.
Yeah.
One of them is taking in the cold air before it goes in.
The intake, yeah.
The intake. And those two things are rotating in opposite directions of each other and moving in opposite directions through this device.
Right.
And he claims that because of this arrangement, for whatever reason, it causes this spinning to become self-sustaining, and it grows in amplitude, and it ends up creating these like implosions.
Right.
And these implosions are creating plasmoids. And he says it's the plasmoids that are having whatever effect that he's.
So that's what's changing the state of the gases leaving the engine.
Yeah.
The intake is coming in.
To my understanding of mechanics, which is zero, like it's all over my head. I don't know if this thing is real or not.
The thing that he brought up on stage and the way that he did the presentation, the way he described the math of how it works. Like he talks about like the spirals, basically, like but it's spirals on top of spirals on top of spirals, and they're all moving in the only way that they all can move in the same movement, right? So one fluid movement, and you got all these spirals moving in such a way that it allows it. And for some reason, that like a lot of the geometry has a lot to do with it.
Yeah.
It's very
also
interesting.
like he shows like a modified version of the table of elements, like in a toroid pattern.
Yeah.
With like the elements arranged in spirals moving out.
Moving inward.
Moving out from inside and then wrapping around. And they're arranged in that way to show different relationships like color and pitch. And so this starts to like sound like the Terrence Howard interview on Joe Rogan a little bit. So, and you know, God bless Terrence Howard, but 1 + 1 = 2. Or 1 × 1 = 1. He thinks 1 × 1 = 2.
That's right.
So some of his stuff is Terrence is another one of those people. Like he's clearly pretty smart, but it would be like me trying to explain quantum physics on the Joe Rogan show. Like I can't do it.
Right.
Like I may have certain concepts, I may have certain terminology and buzzwords.
You haven't been doing it for enough time. Like,
and yeah, I don't have a mastery of the subject. Like I'm not a scientist. Right. But he's also doing other things like claiming he invented a drone that can fly in space. It was like, it's just a drone, man.
Yeah,
can't fly in space. There's no air for the blades to push off against.
But he was saying the movement of it created the force. He doesn't need the blade. Like, and he was talking about all these weird shapes he can make. And I know that thing sounded cool in a sense. Like if they could find something that was like that, there's definitely a lot of applications for our lives. But the thing is he's got a patent for it, but you can get a patent for things that aren't usable.
So just because it's like sounds similar doesn't mean like, because I don't take Terrence Howard very seriously. I think he is interesting. I think I like hearing what he has to say. I think it's fine that he has to say it.
Right. I don't think
no one should confuse him for a physics or a math teacher. He's an actor giving his opinions in scientific fields. Like if he... Yeah, anyway, back to Malcolm. The reason I brought up Terrence was because they both had kind of a similar... It's
based on geometry.
Different arrangement of the periodic table.
Yeah.
And I heard... So I watched a lot of like scientists rebut Terrence Howard on YouTube. And I think a lot of them were unfair in certain areas because specifically they took issue with the periodic table, right? And they said elements have color or elements have a frequency, the key of C. Like what? No, they don't. And most of them just leave it at that.
Right.
But the fact of the matter, in my experience and what I've always heard is everything everywhere resonates. Yeah. Everything has a vibration.
Yeah.
And if anything, if everything has some sort of vibration or if everything has some sort of frequency that causes it to resonate, frequency is
a big part of these
fractal.
Elements.
It can go up and down in pitch. And so, yes, it's not that Terrence is saying that like hydrogen produces the key of A. What he's saying is that whatever resonant frequency that hydrogen resonates with, if you were to convert that into the audible range, that frequency, what you would end up with is a note that we now call A, right? So whatever, like, I don't know that that's useful.
Right. Just the fact that it's there.
I don't even know that
doesn't mean that
I don't even know that his claims on what elements have what frequencies are true, but the idea of an element having a inherent like resonant frequency seems like a no-brainer to me.
Yeah.
I didn't see any of the scientists who rebutted him like give him any thought for that. And I thought that was a little weird. Anyway, so Malcolm's periodic table does a similar thing, and he associates different like any element that ends up in this like the same cross section of this toroid that is they're laid out on. They do that because they share the same like frequencies. Is essentially
in a scale, basically,
right. So it's really similar to the other periodic table that Terrence showed.
At least for that specifically, because I watched Kurt J. Mungle, and he talked about it with one of his guests about Terrence Howard stuff. And they were basically talking about the fact that, yes, or it was somebody we would both know. Anyway.
Yeah. I think I caught some of that.
And he talked about and he was pretty fair towards Terrence about that. And he was basically saying
he was encouraging that type of like curiosity and drive.
Yeah, because we understand the frequencies but with the standard periodic table that we're used to is categorizing them based on their atomic numbers, right? Like they're characterizing them, and they're categorizing them based on certain weights. And if you're not weighing the frequency, you're not gonna assign them any kind of or color or whatever. Mm-hmm. Like you're not gonna the frequency that makes up the color. Right. Like you're not gonna put them in a way or structure them in a way that combines those or like puts them on a scale against each other. But if you do that, then you might come up with a periodic table shaped in the way that he's describing. So that one could be be pretty legitimate. And plus his research is not his own research. It's somebody else did a lot of that research. The current table of elements
that we use, and anyone who hasn't looked into this may not know, is it's not that it has come down on high. There are and have been multiple periodic tables throughout history.
Changes, yeah.
The idea of a periodic table is to try to lay out a reference of all the elements in a way that could help in making future associations that are useful for chemical purposes and for the purpose of forwarding science. Mm-hmm. And so the way our current periodic table is arranged is it goes from left to right and top to bottom. So the first element is hydrogen, and then we go off to the left to helium, and then as you go further to the right and further down, you're going up in atomic number. It's all arranged by atomic number because that's the number one of all like properties of an atom
that differentiate
the most important thing that differentiates one atom from another is how many protons does it have, and that's the atomic weight. And then there's
that's
also
the best
how
way to
many
get them
neutrons
in
can get in there, and that's where you talk about the different isotopes, right? And some isotopes of each element are more and less stable. Now, according to like Terrence, if you use this like frequency way of mapping out that you can find other uses and other relationships. And I think that's a reasonable claim. I don't know that he has any proof for it.
Right. Like his assumptions
it's
of
a reasonable idea anyway.
Yeah. His assumptions are that the frequencies, because they arrange differently, they allow for the idea of transmutation based on this vibrational scale,
right?
And the communication between nitrogen and helium and using frequency is a lot more feasible than using any other chemical way to accomplish it, is what he's saying.
Right,
but
right.
If that's practical or if they've actually done it, he didn't really say. Like he just says it's possible. He says, I got patents on all this stuff, but I don't know that.
Right. And me as like someone who like tries to keep 1 foot in science and 1 foot in like crazy theories and ideas and speculation, it puts me in an awkward position because I see both sides, right? And I don't know how to resolve them. I'm not smart enough to like but like, you guys are talking past each other in this way. Like, maybe I could help a little, but it seems like if Terrence has anything to his point, like there's a whole bunch of like fundamental physics and experiments that need to be done to prove it out.
Yeah.
And that's why your normal physicist will reject it because, okay, cool, this is a nice thing you said. Do you have anything to show me to make me have any thought that this might actually be true, or
especially because
more
his
than just an
claims
idea?
are a lot of these just fantastical claims where he's like claiming like all of general like relativity and all of these things are just wrong, and he's got the news, this whole
sun,
new fundamental
spits out, gives birth to planets by just spitting them out, which that doesn't work for me in my head, but yeah.
Yeah, I mean, it could be that things happen differently in a certain age of the universe, or like when things were forming, or like, I don't know, but I'm just saying the evidence is not there. And I know that I would listen to...
He's essentially getting rid of gravity. I think essentially what Terrence Howard believes is like a version of the electric universe theory. Yeah. But I think he explains it poorly. Right. In electric universe theory,
science communication skills are lacking.
They sort of downgrade gravity in importance and upgrade electricity, like
electromagnetism. Yeah.
Right. And claim that is sort of like the main thing that interacts between heavenly bodies and whatnot. Right. And that's where you get like theories like the Grand Canyon or the Great Canyon on Mars being like evidence of a lightning strike, like a bolt between planets. Right. And you'll hear people talk about that. It is a really cool theory.
I know, just to maybe finish this off, I heard...
Yeah, we totally got sidetracked off of Malcolm, though.
Yeah, we'll have to come back to him.
To be a Terrence episode.
No, we'll come back to it, though. We're probably going to cover some more of the Cosmic Summit on our next episode, and we'll probably do the same thing where we tangent and go all over the place. And
we'll this is a bunch of new material. I didn't even talk about Chris Cottrell's stuff, which he spent most of it
Johanna James has some cool stuff
Carolina
too.
Base. What did she talk about?
She talked a lot of like artifacts and stuff. I caught bits of it.
Okay.
I just kind of jumped through it a little bit, but then I'd have to refresh myself, but I'll refresh myself a bit. But it was interesting. I don't have enough information to give you really an idea of what she was talking about, but it was cool. And we'll anyway. But what I was going to say is I was watching a video that Neil deGrasse Tyson, because Terrence brought Neil deGrasse Tyson up in the episode, and how he sent him all his whole papers, his 36 pages or whatever that he had. And Neil was like, this is what actually happened. I sent him a really well thought out, and I criticized everything, but I did it the way a scientist would do it to any other scientist, just all politics and all feelings out, aside. And I gave him all the, refutations to all of his things. And he basically kind of boiled it down to saying that Terrence has a kind of like the Dunning-Kruger effect, where a lot about you are able to absorb
about a lot.
Yeah, you're able to absorb a lot of this information, but you don't know. The thing you don't know is how much you don't know.
Right.
So you have a lot of this information, and you're able to process it, but you don't know what to do with it. You didn't actually do the work, the 10 years of research on the topic, and you're just kind of
or the math,
right? You don't actually know what you're saying. It's just that you have
which is
very
really
high confidence
what physics is, right? Like, it's actually like, if you try and tell someone you have a theory and then you give them like paragraphs of words, they're gonna be like, where's the theory?
Right.
Because like, where's the math?
Right. Yeah. Give me something to work off of here.
Yeah, because if you give me the math, I can go play with it and see if it checks out, or if it has anything to do with reality.
Otherwise, it's just all theory and it's all philosophy.
Right. These are just words and philosophy, which is fun and I think at times important too. But like, it doesn't refute physics, right? My biggest problem, honestly, was the 1 times 1 thing.
Oh, yeah. Yeah.
So I just want to say this. If any of you out there watched the Terrence Howard thing and you came out thinking 1 times 1 actually might be 2, let me explain really simply why that is not true. When we say times is a shortcut for multiple rounds of addition. Okay?
Right.
So when I say 2 times 2, I'm going to add the number 2 twice. So I take a 2 and I take a 2 and I add them. Now I have 4. Now if I say 2 times 8, I could do 2 plus 2 plus 2 plus 2 8 times, right? And end up at 16. Or I can invent multiplication and realize that there's patterns, and that when you add things, the same number to itself repeatedly, certain patterns emerge.
Yeah.
And so we can use the shortcut called multiplication. So, but all multiplication is adding multiple times.
Yeah.
So when you take 1 times 1, what is that actually saying? You're saying you're going to add the number 1 and you're done, because there's nothing to add it to, because you're only adding one of them. So you're already there.
Yeah.
So add 1
to nothing.
That's the end of the statement.
Yeah.
Add 1.
Yeah.
To what? Nothing, because I only have one of them. So 1 times 1 is 1, because I only have 1 to add to anything, like just the 1.
Yeah. If you want simpler terms, there's a show called Number Blocks on Disney Plus. It'll describe. It'll help you.
So if anyone is like, "Oh, math is so hard," and listened to Terrence Howard and got convinced, hopefully that can help you out a little bit.
All right, y'all. We are over time a little bit, and
so yeah. What did you guys think of today's episode? What did you guys think of the Cosmic Summit? Did you
were able to
check it out at all? What was your favorite talk? What do you think of the topics we discussed? Send us a message on Facebook or Instagram, or a comment on YouTube, or send us an email to hosts@dualitycheck.net. If you want to check out all the links provided on YouTube, it'll be in the description. On podcasts, it'll be in the show notes. If you don't see our descriptions, you can always go to dualitycheck.net/episodes /27. So whatever episode we're on, you just dualitycheck.net/episodes /whatever that episode number is. And yeah.
Yep, I got nothing.
That will be all. So we will see you guys next week to talk more about the Cosmic Summit and some of the other talks that I can hopefully watch without falling asleep this time.
We're gonna have to do a couple episodes back to back here soon. Get ourselves a little lead.
Oh yeah, for sure.
We'll be back at you next week.
Adios.